Hello class again, and welcome to this particular video. And in here we're going to continue from where we stopped, where we're going to be looking now at systems of equations instead of looking at graphing used to determine the point of intersect. And in here there are two ways of going about system of equations. One way is by substitution and the other method is by elimination. But for this particular course we'll be looking mainly at examples dealing with substitution technique. And in here, when you're given two equations, which is presented as this, equation 1 has m1 b1 and equation 2 has m2 b2, what we have to consider in substitution technique first is to combine both equations together. And once you do that, you will be able to find one specific variable. In this case, I have to put in y on the other equation and then actually solve for x, and by doing that I am able to determine what the x of that particular point of intersect is when I have to subtract b1 from b2 and divide your answer by the subtraction of m2 from m1. And once you do that, you're able to determine what x is. And once x is determined, what you have to do is put x either in equation 1 or equation 2. But in this case, we're going to put it in equation 1, and by so doing, you'll be able to find the y, which is the outcome of that particular intersect. So that particular point of intersect is actually giving us the y value, which is represented as m1 multiplied by everything inside the bracket plus b1. And if you want to get back your original equation, all you have to do is just sub in your x, which is given in there, and you'll be able to get your original equation. So the big takeaway here is I'm able to determine what the x and the y is for that particular point of intersect. Now the other technique is by elimination, which in here is not really too complicated. All you have to do is to express both equations picking one variable that has coefficients that is actually the same. So if you have the coefficient of a specific variable that is the same, then you subtract, and by so doing you'll be able to determine or make one of the variable. You must make one of the variable to be equal to 0, and once you have that, the other variable you have to solve for that, and what you get is the x, which is not coincident, it is actually true. It means here that whatever you do in the by substitution or by elimination, you will get the same x no matter what. And once you find the x for that elimination, which is the same as the substitution technique, you actually put your x value either in equation 1 or equation 2. In this case, we're going to put it in equation 1, and what we get is our y, and our y is indeed the same expression as that of the substitution technique, and this actually gives us the y of that specific point of intersect. And in this particular elimination technique, if you want to get back that original expression in terms of 0, what we have to do in this case is you put in this particular expression gotten from equation 1 when rearranged, and once you're able to do that and rearrange all the equations, you will arrive at 0 is equal to the rest of that particular expression right there. So the big takeaway message here is that either you do substitution or elimination technique, you will always get the x and the y. That is actually where the point of intersect occurs. And so in this particular point, what we see is that both x expression and the y are the same. And in here, once we actually perform substitution technique or elimination in both equations, we will on the graph identify the x, which is expressed as b2 minus b1 divided by m1 minus m2, and identify the y, which is equal to m1 all multiplied by b2 minus b1 divided by m1 minus m2 all brackets closed plus b1. Now you've seen the intro video on telling the differences between substitution and elimination. In here we're going to focus mainly on the substitution for this particular course and how to determine the point of intersect. So in this particular case, what we're going to focus mainly on is how to actually deal with problems and not only solving those problems but making that connection back to what the point of intersect implies when you have two lines actually coming together. So in here, these are the techniques required. First step, as always, is to pick one equation and solve for one of the variable, and the second step is to actually substitute the expression that you determined from step one into the other equation, and this is followed by solving for the other variable. And once you actually do that, use this new value in step one equation to determine the other variable. And once you're able to do that, finally is to state the solution and include values or units for both variables. So in here we're going to be seeing how one variable actually relates to another variable when you're combining two different relations and how those two relations are actually common. So looking at this example here, we have question 1, which says that we have one particular equation which we're going to make this line 1 and this here to be a line 2. And we see here that line 1 has an equation 2x plus y is equal to 3, and the other equation is 5x plus 4y is equal to 6. So in this case, what we're going to do is follow the steps. So looking at the solution to this particular problem, first is follow step 1, which means that we are going to pick one equation and solve for it. So first off, we're going to write both equations down. 2x plus y is equal to 3, and for line 2 we have 5x plus 4y is equal to 6. So if we pick one of the two, one criteria I will want you to actually follow is to look at one of the equations and say which variable has the easiest way to solve for. So what we see here in step 1 is that in line 1, which is this right here, we see that y doesn't have any coefficient, that is 1, and 2, it is a positive value. So in here we can solve for y straight up, which means here that our y is equal to, we're moving our 2x over to the other side, which means that we're going to have positive 3 minus 2x. So in here this is easy because we have already performed our solving for that particular variable, which is our y. So in here our step 2, which is now looking at how to substitute this into step 1 equations, which means here for step 2 we're going to pick this particular equation here and substitute it into either line 1 or line 2. So I'm going to write it here, substitute this equation, which is the green, is also written as 2x plus 3 bracket close. And the reason why I'm putting a bracket is to prevent any form of mis-sign calculation. Sometimes if you have a negative sign somewhere, that particular bracket tells me that the negative sign is applied to everything in that particular expression for y. So we're going to put it in the other equation, which is the best way to go about it, because if you pick the same equation that you actually solved for that variable, you will get no value or no solution in there. So in here we're going to do the other equation, which is in this case we're picking equation line 2. So once we do that, then it means here that in here our 5x, which is line 2, plus 4y is equal to 6, and where I say y I put bracket negative 2x plus 3. So in here 5x plus 4, and don't forget to put the bracket, minus 2x plus 3, and in here we have our bracket closed, and this here is equal to 6. So in here we're going to solve by removing the bracket, which means that we're going to do or perform our distribution where our -4 or +4 will be applied to this particular variable and this particular equation, right, number right there. So which means by distributing, it means we're going to have our 5x, which we're going to rewrite down, plus 4 times -2x, and the next one here is plus 4 times +3, and this here is equal to 6. So in here we have our 5x, +4 times -2x gives us -8x, and +4 times +3 gives us +12, and this here is equal to 6. And once we have that, we'll give more room so that we can solve for x, and in here we could actually solve for x, and in here we have all x on one side, but we have a constant on the left side, so we're going to move that over to the other side so that we can be able to solve for x. So we're moving the constant, which is +12, over to the other side, which means here that we have 5x minus 8x is equal to 6 minus 12. So on the left side, 5x minus 8x gives us -3x, and this here is equal to 6 minus 12, -12 gives us -6. And in here, solving for x, we are actually dividing both sides by -3, and in here our x is equal to 2. So we have solved the first part in here, which is actually under the concept step 3. So in here, this is where step 3 actually kicks in. So step 3 is to actually solve. And now moving on to step 4. Step 4 means that we are going to put our variable solution, which is this time x is equal to 2, back into one of the two equations. So for step 4, once we actually do that, we are going to, let me write it here, use the new value and put into step 1 any of the two equations. So in here I'm going to pick, looking at the equations, we're going to pick equation 1. Equation 1 says that y here is equal to, after solving for y, is equal to -2x plus 3. So in here, when we let our x to be equal to 2, which is actually gotten from our new value here, we actually put x equals 2 in this particular equation, so that we'll be able to solve for y, which is the goal. So in here our y is equal to -2, where I see x I put 2 and bracket closed plus 3. So in here y is equal to -2 times 2 gives us -4 plus 3, therefore y is equal to 1, sorry, -1. So that is about it in here. We are able now to actually solve for our y and x, which actually makes us to realize that yes, for our step 5, we know that x is equal to 2 and our y is equal to -1, which means that the solution, or the point of intersection between the two lines, is actually when x is 2, y is -1. So that is it for this particular example that we actually solved what you need to consider now is please follow the same strategy that we did here. For example, we want to solve this particular question here, which is solution or solving for this next question. And what I want you to do is to, let me give you a guide on how to solve this problem. First off, as always, is pick one of the variables either in line 1 or line 2, and pick one of the variable, which means that in here, if I pick equation 1, you can pick equation 2, it doesn't matter. Once you pick equation 1 and you solve for y, you have your y to be equal to x plus 1. Now in here, once you have a y to be equal to x plus 1, we need to determine what the x is. What is x? Which means that I'm not going to put my y equals x plus 1 in equation 1. No, I'm not going to do that. I'm going to put this in equation 2. So in equation 2, once you put that in equation 2, what you're going to have is your x value after solving is going to be equal to -1, which is awesome. So once you have that actually determined, our next step is to put your x equals to -1 in either equation 1 or equation 2. So once you do that, or simple and short, just put it in this particular equation. And once you put it in that particular equation, we are going to determine what our y is. And our y in this particular question will be equal to 0. So therefore, this point of intersect between these two lines is known to be when x is equal to -1, our y is 0, which is actually in this case the x intercept. So that is it for this particular question number 2. And number 3, in here, the same strategy that you performed both in 1 and 2, you do that in this particular question. And what we see here is, let's for example pick now line 2 and let's solve here for a specific easy variable, which is in this case y, because y doesn't have any coefficient, or it has a coefficient which is 1, a +1, and +1 is easy to solve. So once you solve your y, we notice in here that our y is equal to -6x minus 10. And once you do that, you put it not in equation 2, but you put this expression, don't forget the bracket, in equation 1. And once you put it in equation 1, you're going to now determine what your x is. Once you do that, you're going to solve for x, and x in this particular expression is going to be equal to -2. So now you know your x to be equal to -2. Our next step is to actually find the y, which means I'm going to put my x in this particular equation, and to solve for my y, it means here that my y will be equal to 2, which is indeed what we have there, because -6 times -2 gives us +12. +12 minus 10 gives us 2. So therefore, in this particular case, my x is equal to -2 and my y is equal to 2. So therefore, the point of intersect is when x is 2, y is 2. And finally here, this challenging question, the same strategy again. In here, we're going to solve for one of the variables. What we see here is that x, on the second line 2, we see that x actually is alone, 1 and 2. It is actually a positive value, which means that it's easy to solve for x. So in here, what I would suggest you do is solve for x. And once you solve for x, x is going to be equal to -8 plus 4y. So once you have that bracket included in there, then you can put this into your equation 1, which means here that once you put this in equation 1 and you solve for your specific x, no, this time you're not solving for x, you are actually solving for y. and once you solve for y, your y in this case will be equal to 4. And once you determine your answer for this particular y to be equal to 4, now you have to put your y either in equation 1 or equation 2, but I would suggest you put it in this particular expression for x. And once you do that, you can then determine what the x is, and in here your x is equal to 8 after solving for x. So therefore in here, when our x is equal to 8, sorry, I put 8 is equal to 8, wow, which is true, but here x is equal to 8, our y is equal to positive 4. So therefore the point of intersect between those two lines is when x is 8, y is 4, which is actually the answer after solving for that particular point of intersect in that particular equation. The only difference here is that we are actually first solving for x compared to equation 3, question 3, question 2, and question 1, where we actually solved for y. And once you do that, you'll be able to find the other expression in there for your y. So what I want you to do for homework is to go through these questions. You can find them also in your Hapara space, and please send this to me so I can check it out and see whether you're on the right track in there. And please don't forget to follow the substitution method in order for you to actually determine what the x is and the y is. One hint I will give you is looking at A, please solve for x looking at the equation 2. If you look at B, you can either solve for x or y, but I would suggest you solve for x first. For C, y is already solved for, so you can just put your y in line 2 back in line 1 and find what x is. And from there, once you have your x value, you can put your x value back into any of the two equations to find your y. I would suggest you actually put your x new value in the line 2 equation to find what the y is, because it's easier to solve. For D, in here we see that line 1 has y to be positive 1, so it's easy. You can solve for y here first, put it in equation 2, solve for x, and then once you solve for x, put your x new value back into line or expression 1 when you solve for y to find what the x is. And for E, in here our x is kind of different, but it's still the same concept. But I would suggest easily you just pick line 2, solve for x, because x is positive 1 for the coefficient, and then in here you put your x expression back in line 1 and you solve for y. Once you have your y value, put your y back into one of the two equations, and then you solve for the x value. And in here for F, we see here that we have x to be positive and it's already solved for, which is 5y plus 2. You put that in equation 1 to solve for y, and once you find your y value, you put your y value in equation 2 to find the x value. And for G, we have this particular equation right here, and in here what I'll suggest you do by inspection is to solve for y in equation 1, and then once you do that, that's pretty much one step easy. You just put that particular expression for y in equation 2 to solve for x, and once you have your x value, you put your x value in either equation 1 or equation 2 to solve for y. And that is it for A to G. Variations, but still the same concept to actually notice. And for the bonus question here, you're actually given now all x and y's having their own coefficients. So all you have to do is do one additional step, which is after picking a variable that you want to isolate first, I'll suggest you do equation 1. If you want to solve for x, it means they are going to divide both sides at the end by -7, and once you do that, you're going to have a fraction, and what you do is you put that fraction in either mainly equation 2. Put it in equation 2 to solve for your y, and once you find your y value, put your y value back in equation 1 or equation 2 to find the x value. So that's about it for this particular video. Hope you're able to understand this concept of substitution used to determine the point of intersect between two lines. And that's it for chapter 4 and dealing with linear equations. All the same, please don't forget to send me an email if you have any questions. By that way I can get to you, or through Google Meet. All the same, stay smart and believe in yourselves and stay healthy.